Alright, welcome to Unit 4.06. We're going to be solving radical equations by hand and using technology, and you'll see what I mean by that in just a minute. So let's get some extra practice solving radical equations by hand, since that's the way we know how to do it, by taking a look at these questions here. Alright, so go ahead and solve these for x. Make sure to check your work, right? So once you get a solution, go back to the original equation and make sure it works. If you need to use a calculator, that might be helpful, just to make sure that your values are perfectly correct. Okay, so for the first one, here I've just got to isolate the radical by dividing on both sides by 2, and then I need to square both sides. So looking forward, I would divide by 2 and square root both sides, so I would end up with x minus 1, square root of x minus 1 is equal to 5, and then I can square both sides to get x minus 1 is equal to 25, and therefore x is equivalent to 26. So if I go ahead and plug that back in, the square root of 26 minus 1, well, 26 minus 1 is 25, square root of 25 is 5, and 2 times 5 is 10. Down here, a little more work. If you struggled with this one, and this helped you out a little bit, make sure you go back and try this one again. I'm going to post the solution rather quickly. Alright, so to run through this rather quickly, I will subtract 6 from both sides, which will give me 9 on the right side. Then divide by negative 3 on both sides, which will leave me with negative 3 over here, because 9 divided by negative 3 is negative 3. I've isolated my radical, so I'll square root both sides, and that will get me x over 2 plus 3.7 equals 9. And from there I can solve pretty easily by subtracting 3.7 from both sides and multiplying by 2. And I will end up with x approximately 10.6. But we've got to check to make sure this actually works. So go ahead and plug this back in, and we can kind of estimate this in our heads, see if it'll work. So 10.6, let's just call it 10. And so, 10 divided by 2 is 5, plus 3.7, that's, 8.7, call it 9, right? Close to 9. Square root of 9 is 3. 3 times negative 3 is going to be negative 9, and negative 9 plus 6 is not 15, right? It's going to be negative 3. And so this here is going to be an extraneous solution. Remember, it's a solution that arises while we're solving that doesn't actually satisfy the equation. And we talked about this. This is going to happen a lot when we square both sides of an equation. So we've got to check. And this, of course, doesn't actually work, right? And the reason that is because when we're taking the square root of something, we're taking the principal root, or the positive version of that number. And so it will sometimes be the case that what we end up with is not going to work. But the key thing to remember here is that we can solve these by hand, and they're not too hard. Let's now take a look at a couple more. So go through and solve these. Get creative. You might need to do so in order to solve these, but don't spend any more than 3-4 minutes on each one. All right, so these are pretty tricky, and I'm going to go through them rather quickly because I want us to talk about a potentially faster way of getting this done. Okay, so I have 2 radicals here on the left side, and what we'd think is, okay, we're going to have to square something at some point. When should we do that? And you might try getting the radicals on either side and squaring both sides, and you could get there that way. But what I'm going to do is I'm actually just going to go ahead and square the left side, the whole left side, and the whole right side. Okay? And so this left side here I'm going to need to FOIL because I have a binomial here and I'm raising it to the 2nd power. And let me go ahead and show you what that'll look like. It's not as complicated as you might think. You just have to be willing to give it a try. So what I've got here is square root of 3 minus x plus square root of x plus 2 multiplied by itself. and you've just got to take these as if they were any other number that you were foiling, any other two binomials. So, of course, I'm going to multiply the first two terms, and when I multiply the first two terms, I'm going to end up with, well, the square root of something times itself. So the square root's going to go away, because this is really squaring, I'm multiplying by itself, and so I'm going to end up with 3 minus x. Okay. So I've multiplied the first two, and then I'm going to multiply the first and the last. And what I realize here is that I'm going to get these two square roots multiplied by each other. And when I multiply these two, I'm also going to get these two square roots multiplied by each other. So I'm going to have two of those. So plus 2 times the square root of 3 minus x times the square root of x plus 2. And that might look daunting at first, but just realize it's 2 times this times this. And it's not going to be that bad. And then last but not least, I have the last two square roots, and these are the same thing multiplied by each other, so they're squared. And so when I square root, or when I square the square root, I'm left with x plus 2. So plus x plus 2. And on the right side of my equal sign, I just have 9. And let's collect some like terms here. So I have negative x plus x and 3 plus 2. So negative x plus x goes away. 3 plus 2 is 5, so I'm left with 2 square root of 3 minus x times square root of x plus 2 plus 5 is equal to 9. And subtracting 5 from both sides will give me 4 on the right side. And I can also divide by 2, or multiply by 1/2 on both sides, so that I can get rid of that leading coefficient there. And so now, on the right side, I have 4 times 1/2, which is 2. And on the left side, I have the square root of 3 minus x times the square root of x plus 2. Okay? And now, I'm going to notice something. I have two things multiplied by each other that are square rooted. So if I square both sides now, well, I'll be able to apply the square to both pieces in here, and I'm going to get rid of the square roots. So I can square both sides. And what I'm doing is I'm just applying the square to both pieces. And so I'm going to end up with 3 minus x times x plus 2, right? Because I've just squared each square root individually. Okay? And at this point, I can multiply these out, and I'll let you go ahead and try and solve it from here, and we'll talk about the solution in just a second. Okay, so when I FOIL this out, I'm going to get this quadratic here, and I can subtract 4 from both sides, and I'll end up with a quadratic that I'm trying to make equal to, set equal to 0. So x squared plus x, and I've subtracted 4 from both sides, so I'm going to have plus 2. And through a little bit of work, we can actually factor this. And when I factor it, like I did over here by factoring out the negative and then splitting up the quadratic into two factors, I see that my two factors are x minus 2 and x plus 1. And so the values that will make this quadratic equivalent to 0 are going to be x equals 2 and x equals negative 1. And there we go. I found my solutions. X equals 2 and x equals negative 1. And I can go back to my original equation up here, and I can plug in 2. So square root of 3 minus 2 is 1. Square root of 1 is 1. And then I have 2 plus 2. Square root of 2 plus 2 is square root of 4, which is 2. And I have 1 plus 2, which is 3. And I could also try negative 1. So I plug in negative 1, and I get 3 minus negative 1, which is 4. Square root of 4 is 2. And negative 1 plus 2 is 1. Square root of 1 is 1. And so I have 2 plus 1, which is 3. But that was a lot of work. A lot of work. And if you went ahead and solved this one, you'd see that you got into the same boat. And I encourage you to go ahead and try that again, seeing this root. This is a lot of work. And so we want to think about a potentially easier way of finding solutions to some trickier radical equations. What I want you to think about is another method that we've spoken about before for finding the solution, meaning the x value that makes the equation true, to any equation where we have f of x equals g of x. In other words, just something equal to something. What are some other ways besides solving by hand that we can figure this out? Hopefully what you're remembering is that, well, we can graph f of x, we can graph g of x, and if we look at the graphs of each function, so let me graph two, let's say this is f of x, and here is g of x. Well, where they intersect is going to be the solution, right? That's the x value, right? This is the x value that makes the two functions equivalent. And so I found it. And so if we can go ahead and graph f of x, and we can graph g of x, then we can find where they intersect. Okay. And so what I want you to do is I want you to go ahead and give this a try. I want you to go to Wolfram Alpha, and I want you to try this with each equation. So let's just take the first one, for example. This first part here, right on the left side, that's my f of x. And I want to know when that is equal to g of x, which just happens to be 3. So we've talked about before how you can graph each function and see where they intersect, and Wolfram Alpha is really good. You can actually tell it to solve, and it will do that and find that intersection point. So what I want you to do is I want you to go to Wolfram Alpha right now. I want you to post in your comment, I want you to post what you typed into Wolfram Alpha to solve this. So remember that plot or graph will graph it for you. I want you to type it into your comment so that if someone is confused or having trouble, they can use yours, okay, and try and figure it out. And your goal is to type out in your comment what you typed into Wolfram Alpha and then what the solution is to this first one. And then go ahead and try that with the second one, and we will do a little more work on it in class.